Hi, software engineers. We're going to continue talking about MVC today in order to get to REST, as in the Representation State Transfer Architecture. But to get there, we kind of need to take a little bit of a journey. We need to go through some of these architectural design patterns that we've talked about and also introduce a few more. So here's a quick kind of introductory video to what you need to know. Let's review first. So here we have Model View Controller. So remember, the idea of Model View Controller is that we have split out the data, which is the model, the presentation, which is the view, and the controller, which is the business logic or the application logic. So in this example, we have a browser that is sending a request to a web server that is then interpreted by the controller in some way by reading the URL, reading the parameters that come in, and using that information kind of like a method call to say, okay, you want this page that lists all of the students in the class. So let me go get all of the students from my model, and the data model hides the abstraction or hides the implementation of exactly how the data is stored. So there could be a MySQL database, there could be Postgres, there could be a flat text file for all you know, but if a framework is doing its job right, you just have to say, give me all the students. So you get that information back, and then you go to the views, and you say, okay, give me a template HTML page that I'm going to use to then build the dynamic page that's going to be sent back to the user. And in this way, we can build interesting, effective, dynamic web applications. Now, MVC is not just a web architecture. It's used extensively in mobile in a very similar way, but we're going to worry about it here in the terms of web. So what are you trying to solve with this particular architectural design pattern? Well, that separation of concerns is very important. If you need to make a change to the user interface, it's not going to affect the way you've stored the data, or it's not going to affect the way that you've written the business logic. If you have to change something about the business logic, all of a sudden you say, I only want to be able to list students who are currently enrolled, then you don't have to make any changes to the data. You just make the changes to the controller, then that's apart from anything else. Let's say you have to move your system to a new server and you have to use a different database. Well, if you've done the model part correctly, you can swap out the database. As long as that model abstraction is still there, then the controller can still use it. So this is really, really powerful. Also, it allows you to split it out between sub-teams. So you can have a user interface team that's going to go work on the view. You can have, a data modeling team to work on the data, such on and so forth. Also, it's extensible. If you want to add new pages, well, you add an appropriate controller, add some new templates, and adjust the data model as needed, and now you can keep building out your website. Exactly what you're doing with Django right now. So, like I said, it's not unique to web applications. It's used extensively in mobile. We talked about this in the last video, that an Android app has an activity.java that is the page that you go to, the screen that you go to. An XML file is loaded that is the view, and then some database like SQLite is used on the back end. But you can also do it on regular desktop applications too, as long as you set it up right. Now, Model View Controller is kind of the end of the journey when we're talking about the architectural design patterns along the way. So you want to use MVC because it allows you this really systematic, reproducible way of building really nice pieces of software that a new developer can come in and say, oh, I know what the model is, I know what the view is, I know what the controller is because I've done another programming language, I've done Ruby on Rails, I've done something like that. So they can look at a Django app and pick it up really quickly. For maintenance purposes, this is extremely important. You want new developers to come in and not have to spend 3-6 months just learning, oh, that's in random.java over there. They should be able to look at the architecture and figure out what's going on. So the team chooses an appropriate Model View Controller framework based upon things like, what are your constraints? What are the comfort level of the other people on the team? What is the comfort level of the organization? What are the existing code and libraries that are out there? So we chose Django because most of you know Python. Basically, all of you do. There are a few people who are coming in without Python experience, but not a ton. That's okay. But, in general, this is something that's comfortable for you, and it's easy to pick up. Django has been around for a long time, relatively speaking, in programming terms. So there's mature libraries for it. There is plenty of documentation for it. There are plenty of examples for it. Django and Python runs on basically anything pretty easily, so that's really, really handy. And for the purposes of this class, Django is an excellent example of model view controller and allows us to teach some of these architectural design patterns without much trouble. Now, a few teams for the project have asked about using other parts or other frameworks in addition to Django. Like, hey, we want to use something else to do a nicer looking user interface. Hey, I completely understand why you want to do that. That sounds awesome. But unfortunately, sometimes you don't get that choice in real development. Imagine this scenario. You're on a team of, I don't know, 5, 6, 7 people. Let's just say it's a bigger team for simplicity's sake. And you know how to build just a kick-in front end. But you're going to use HTML and JavaScript, or you're going to use ActiveScript, or some other, something that's not necessarily known to the team. Well, that's great. Maybe you build something really cool, but then as soon as you get transferred to another team, that team doesn't have experience with that code. They didn't help you build it. All of a sudden, the maintenance for that piece of software has gotten really, really tough. So you can't always build a piece of software to the best things that everyone on the team knows. You kind of have to build software to what does everyone on the team feel comfortable with, because the cost of software is not in the building. The cost of software is in the maintenance, is in the updates later on. So for those of you on teams who are beyond us and are doing who want to do cooler stuff, that's awesome. I'm really happy for you that you're interested in doing cooler stuff. This is the reason why you can't do that. This is a lesson that you kind of have to pick up as you go. So hopefully you get a chance to do some of that stuff, in other courses. But we're gonna hold you back here a little bit. Now, model view controller, as I mentioned before, is kind of the end of the story. There are a lot of other architectural design patterns that lead up to MVC that explain how MVC work the way they are. And this story is going to take us through kind of modern web development, which I'll do in the next video, which is going to explain REST. But we need to look at these architectures to get a good feel of it. So we're going to talk about client server and how that relates to 3-tier, which you've talked about. We're going to look at platform, infrastructure, and software as a service, and then we'll get into representation state transfer. So, client server. This is probably a term you've heard plenty of, but you might not necessarily know exactly what it means when we say a client server architecture. So, McBurney touched on this some. I'm going to review it again here. I think it's important to make sure that we're on the same page as far as this goes. In the context of MVC, though, MVC doesn't have to be client server. It often is in a client server system, particularly when you're talking about a website, but in a mobile app, it isn't. So how does a client server work? Well, let's start back with 3-tier. Remember, the idea of 3-tier is the separation of concerns. So if we consider a 3-tier architecture, as I look down here at my drawing pads, you'll see the top of my head for a little bit here. Remember, we can think of a 3-tier as something like, okay, I have a laptop that is going to connect through the internet to some server somewhere that's going to have this is a universal database server, to some database server right here. This is a communication, okay? So this is a 3-tier architecture because we have the presentation layer, which is going to be the web browser. We have the logic layer, the application layer, the business layer, which is the web server right here. And then we have the data layer right here, which is the database. This is 3-tier. Is this MVC? No. MVC is when we take this to code level. So remember the idea of MVC, back to our original diagram, is we had the model here, the view here, the controller here, and a request comes in, the controller gets the information from the two, and then puts it together. Now, we had the user down here, right? Okay. So, in a sense, the view is also kind of down here, because the view is then what the user is going to be interpreting and how the user is going to be interacting with stuff. If you've done any other web development, you know that there's some code that comes with this view. Think about when you use Gmail, okay? Gmail is a system that lives on Google servers. But whenever you hit, load Gmail, you have that loading Google M thing. It used to be an actual loading bar. That's because code is coming with this view down here because sometimes the user experience does have some code in it. Matter of fact, it's a very large JavaScript library, and also it preloads some of your email. So all of a sudden now we have an instance where some of the programming is here with the JavaScript in your initial code, and some of the programming is up here with the actual server itself. So this is a different way of thinking about a three-tier architecture. So with that said, what does a client-server architecture look like? Okay. Client-server means there is a separation of where the processing and data takes place. So in a client-server, you can have a machine here. This is my universal sign of laptop computer. I know it's very exciting. And then some form of communication. This is my universal, the internet, okay, with some abstract entity of a server over here, okay? Now, this could also be a mobile device. It could also be a desktop computer. It could be any sorts of things. And on this side, we might have, I don't know, maybe more than one server that then handles who gets the request. In a client-server architecture, we are separating how much of the processing happens on different locations. So, imagine for a moment you're building an application that's going to work. Let's think about Microsoft Word. Let's do this. Microsoft Word has some server capabilities. It can talk to OneDrive, for instance. It can talk to libraries to download templates. Now, most of us would probably agree that default Microsoft Word, default normal Microsoft Word, the processing happens on this side, right? Because you've installed Microsoft Word, and then there's a little bit of traffic to the server to do, OneDrive backup, stuff like that. Now, how about Microsoft 365? How about the version of Microsoft Word that you do in your browser window? Well, that's a little bit different. The bulk of the processing in that one, so 365 is here, and this is installed Word is here. The bulk of the processing for 365 Word takes place on the server side. And then it's sending a lot more information back and forth because every time you enter information, it's going to get saved back to the server side. But there is still some processing here on this side, on the client side, because that's where the JavaScript libraries live that make it so it looks like an actual instance of Microsoft Word. This is the difference between a thick and a thin client. A thick and a thin client. A thick client is one in which most of the processing takes place on the client. So on the view side, if we're thinking about this in terms of model view controller. So for instance, a mobile app that you install that, if you turn off Wi-Fi or you're on airplane mode, the mobile app still works. That is a thick client. Most of the processing happens there. What about a thin client? Well, it's the opposite. A thin client is one where the bulk of the processing takes place on the server side and very little comes back on the client side. So things like the Microsoft Word 365 example, or maybe something like Facebook. Facebook is on your mobile device is an app that really doesn't do anything unless you have a network connection to get all of the data that you need. There are reasons you build applications to be more thick or more thin. For your project, this is where this ties in, your project is more a thin client. Most of the processing is taking place on the server side. So anyone can log into your application as long as they have the right credentials from any machine, from a laptop, from a mobile device, from someone else's laptop, from a public computer. They don't have to have anything installed. So that is a better model for some web applications, whereas some web applications, like maybe you're playing Genshin Impact or some other, MMORPG where it heavily uses the web because there is an instance where you have to have connections to talk to a server to know where everyone else in your team is or in the environment is, but you have to install something large. That is more of a thick client. Okay? Now, how does that apply to what we are doing with our servers? Well, let's go back to my first diagram here. Platform as a service, infrastructure as a service, software as a service. We are using Heroku, right? So we wanted you to use a system where you had to upload your project to, and the project would just automatically launch and run. This is a platform as a service infrastructure. So a PaaS. Okay. Now, what's powerful about platform as a service architectures is if I wanted to, and if I followed the rules for basically installing everything the right way, like your proc file and everything you're supposed to do to make Heroku work, if I needed to have more servers because there were a lot of people who really like the app, I could add more dynos in Heroku, and all of a sudden I've increased my capacity extremely easily, which is awesome. I love this. This is perfect. This is fantastic. The app that I wrote now is fully scalable. Does this cost more? Yeah, it does, but you're paying for that service. Infrastructure as a service is, I can't seem to do a capital S when I want to. Infrastructure as a service is, I'm just going to rent a machine. So this is your AWS. I just want a machine. Give me a machine. Nothing set up. No, nothing. I will do all the setup. That is the infrastructure as my service. That gives you technically the most flexibility because you can do anything you want to with it, and probably it's cheaper because you're just paying for the hours of the machine. You're not paying for the platform itself, but you're probably increasing your workload significantly. We didn't want that. We looked at using some Google services and also some AWS services for this course in order for you to set up your system. Or maybe we want you to go find your own host and you need to set up your own server to host your application. We decided that was not what we wanted for the course several years ago, and we've continued that on until now, and I've been very happy with using Heroku's platform as a service because you need to learn enough that you can push something to this platform and understand how to work within this service, but you don't have to know how to set up a web server. Now, at the other end of the spectrum is software as a service. Software as a service is, we've already built it for you. This is, I want to have some social interaction built into my website, so I'm going to just integrate Twitter. I'm going to integrate Discuss. I'm going to integrate some messaging system that already exists. I want to integrate payment. I'm just going to integrate Square. Software as a service. I'm adding something of value to my application, but I don't have to program it. I'm just paying to have that service integrated. We are asking you to add a little bit of a software as a service to your application by doing something like, finding a web service that makes sense for what your app is going to do. All right. So, review. We had 3-tier, which remembers the idea of the separation of concerns. We are separating out the view from the logic from the model, from the data. Client server is where do we put the processing? Do we put it on the client or do we put it on the server? And how much do we put where? And the way we make that determination really determines the type of application we're trying to build. Are we trying to build something that lives in the cloud, like your project? Or are we trying to build something that's going to compile and run locally you have to install, like a Microsoft Word or, most video games or, something like that? Well, we are using a 3-tier architecture, MVC, in a thin client environment because it's all going to run on a server. It's going to run on Heroku. And then on locally, you might have some processing, you might have some JavaScript libraries that you pull down, but you're not pulling down a lot. It's mostly running on the server. Okay, if it's running on the server, how is it running on the server? Is it using the platform? Yeah, Heroku is our platform. We don't want to have to pay for all of that. We to build it all ourselves. Do we have to set up the servers ourselves? No, we don't need to set up the servers ourselves. That was infrastructure as a service. That was not part of our learning objectives for the course. Is it a software as a service? Well, we want you to use some software as a service, but we kind of want you to write the thing too. So that's how we ended up with that. So all of these architectural design patterns have an effect on modern web applications, like the one you're building. It's not just a browser interface, okay? They're going to they're going to have ways to interact with other systems. You have to understand, here's how we're putting the pieces together. Here's how it's living on the website using this platform as a service. So this is where our story takes us. When we pick up in the next one, we're going to talk about how the web evolved from the original client-server systems and how they became more robust 3-tier architectures and why we like to use platform as a service and that sort of thing. So there you go. There's your quick overview of all the architectures that we are dealing with when we're talking about MVC and we're talking about Django. Next time, how did the web become the way it is, and how does that lead us to the new type of architectures we care about? So I hope this was helpful. Thanks for watching. I'll see you next time. Bye.